Hello students, Kannan here. In last video we saw exercise 5.2, problem number 1 to 5. Next problem is 6th problem. Differentiate cos x cube sin square x power 5. First let y is equal to these functions. So y equal to cos x cube sin square x power 5. Now differentiate this by product rule. Take this as u and this is v. Okay, we know product rule. Y is equal to u into v. So dy by dx is equal to, write u first, differentiating v plus write v and then differentiating u. Okay, this is the product rule. So dy by dx is equal to, first I write cos x cube, then differentiate sin square x power 5 plus write sin square x power 5, differentiating cos x cube, d by dx of cos x cube. Okay, now I am differentiating separately. Now I am taking u is equal to cos x cube d by dx equal to, differentiation of cos is minus sin x cube, again differentiating x cube by using chain rule. Okay, d by dx of x cube, again differentiating x cube. Okay, so differentiation of x cube is 3x square into 3x square. So we get the answer as minus 3x square sin x cube. Okay, here I am v equal to sin square x power 5. Now differentiating v with respect to x. Here we use a power rule here. So we know power rule. So y equal to f of x power n dy by dx equal to, so n into f of x power n minus 1 into d by dx of f of x. This is the power rule to differentiate. Okay, here f of x is sin x power 5, n is equal to. Okay, now this is f of x, n value 2. Okay, so write 2 first, sin power 2 minus 1 is 1, x power 5, and then differentiating f of x. Now this is f of x, so d by dx of sin x power 5. Okay, d by dx of sin x power 5. So 2 sin x power 5, d by dx of sin x power 5 is cos x power 5, again differentiating x power 5, d by dx of x power 5. Okay, that is 5x power 4. So 2 sin x power 5 cos x power 5 into 5x power 4. That is 5 to 10. Okay, this is the power rule. So 10x power 4 sin x power 5 cos x power 5. This is the value of dy by dx. So we therefore dy by dx equal to cos x cube this is a continuation. Okay, d by dx of sin square x power 5 is this one. So I am by first write cos x cube Okay, d by dx of sine square x power 5, d by dx of sine square x power 5, this one. So 10 x power 4 sin x power 5 cos x power 5 plus v du sin square x power 5 d by dx of cos x cube is minus 3x square sin x. Differentiation of cos x cube is minus 3x square sin x cube. Okay, so we multiply 10 x power 4 cos x cube so minus 3x square into sin x cube. That's all. This is the value of dy by dx. Okay. Next, sound problem. Differentiate so under root of cot x square so y equal to 2 under root of cot x square here we follow square root rule, so y equal to root f of x dy by dx equal to 1 by 2 times root f of x, again differentiating f of x. So in this problem f of x equal to cot x square this is f of x. So to differentiate follow this rule. Okay, so dy by dx equal to 2 times 1 by under root of cot x square again differentiating cot x square. So 2 to cancel, so under root of cot x square d by dx of cot x square d by dx of cot x is minus cosecant square x, so minus cosecant square x square again differentiating x square, that is important. Okay, d by dx of x square, that is 2x. D by dx of x square is 2x. Okay, I am writing here 2x cosecant square x square by root of cot x square. Next we simplify. Cosecant square is written as 1 by sine square x square root of cot x square is cos x square, cos by sine. Okay, cos x square by sine x square. Sine x square. Okay, so this is both are under root. Now root of sine x square to numerator, so minus 2x under root of sine x square divided by sine square x square is written as sine x square into sine x square, to simplify, into under root of cos x square. Okay, So one root cancel. So it become, because under root of sin x square by sin x square, so under root of sin x square, this sin x square is written as under root of sin x square into under root of sin x square. One under root cancel, so we get 1 by under root of sin x square. Okay, so this become minus 2x under root of sin x square into sin x square under root of cos x square. Okay, so minus 2x divided by sin x square, so under root of sin x square into cos x square. Okay, sin x square cos x square, and also multiply divided by root 2. Okay, multiply divided by root 2 here, because we know sin 2x formula, trigonometry formula. Sin 2x is 2 sin x cos x, 2 sin x cos x. Okay, so to bring that formula, I am multiplied it by root of 2, so minus 2 root 2 x sin x square under root of 2 sin x square cos x square, that is use sin 2 sin x cos x formula, so it becomes sin 2x square. So this is the value of dy by dx. Okay, next problem. That is 8th problem. Cos of root x. So y is equal to cos under root of x. Okay, so dy by dx equal to differentiate. Differentiation of cos is minus sine, so minus sine under root of x into d by dx of root of x. This is a chain rule to follow. D by dx of root of x is 1 by 2 root of x. Okay, so we get minus sine root of x by 2 times under root of x. That's all. Okay. Next problem, 9th problem. Prove that the functions f given by f of x equal to mod of x minus 1, x belongs to R, is not differentiable at x is equal to 1. Okay, given function is mod of x minus 1. We know first principle formula. What is f dash of x? Limit s tends to 0 or delta x tends to 0. Okay, this is delta formula, so delta x tends to 0, f of x plus delta x minus f of x by delta x. Okay, this formula is called first principle. Okay, in this formula, to prove the function is differentiable, we find the left hand derivative and right hand derivative. Okay, what is the left hand derivative? For example, I am taking x is equal to a here. This point is x is equal to a. Okay, so in x is equal to a, this is the left neighbor. Okay, this point is called left neighbor. And this point is called right neighbor. Okay, right neighbor. If x approaches a in left side, okay, if x approaches a in left side, the derivative is called left hand derivative. Okay, if x approaches a in right side, that derivative is called right derivative. Okay, left hand derivative means x approaches a, we find the derivatives. Right hand derivative means x approaches in right side of a, we find the derivative. Okay, now this point is taken as a minus h. Okay, this point is taken as a plus h. Here h is a small increment value. Okay, very small increment. H is equal to positive. H is equal to positive value. And it has very negligible value. Okay, 0.00001, 0.1001. Okay, it is very negligible value. Okay, so a minus h means definitely that point comes before a. A plus h means definitely that point comes after a. Okay, so I am writing left hand derivatives. At x is equal to a, so limit delta x tends to 0, h tends to 0. Now I am replacing delta x by h. Okay, limit h tends to 0, left hand derivative just x is equal to a and delta x is equal to minus x by f of a, because we find derivative at x is equal to a. Okay, divided by minus h. This is a left hand derivative. Okay, in left hand derivative, delta x equal to minus h. Okay, here delta x equal to minus h. Then only that point comes before a. Okay, right hand derivative. Here limit h tends to 0, f of a plus h minus a divided by plus h. Okay, so both derivatives are equal, then only the function is differentiable. Left hand derivative equal right hand derivative, the function is differentiable. Okay, to prove this problem, we find the left hand derivative and right hand derivative. Okay, at x is equal to 1. Okay, function is mod of x minus 1. Now f of x is mod of x minus 1. Now we prove that the function is not differentiable at x is equal to 1. Okay, so now write the left hand derivative formula. Left hand derivative at x is equal to 1 is equal to limit h tends to 0, f of 1 minus h minus f of 1 divided by minus h. Okay, now in this formula I am putting x is a equal to 1, h is equal to same h. Okay, so limit h tends to 0, f of 1 minus h means replace x by 1 minus h in the functions. Okay, so modulus of 1 minus h minus 1. F of 1 means we put x is equal to 1 in the modulus functions, 1 minus 1 divided by h minus h. Okay, so plus 1 minus 1 get cancelled. We get mod of minus h minus mod of 0 by minus h. Okay, so we know modulus of minus is plus. This become h minus 0 omitted. Okay, by minus h cancel. So limit h tends to 0, minus 1 is equal to minus 1, take it as 1. Okay, next write a right hand derivative at x is equal to 1. So limit h tends to 0, f of 1 plus h minus f of 1 divided by h plus h. Okay, so limit h tends to 0. In the function is given function is mod of x minus 1. In the function we put x is equal to 1 plus h. So 1 plus h minus 1, already minus 1 here. F of 1 is 1 minus 1 divided by h. Okay, so limit h tends to 0, 1 1 cancel, mod of h is h minus 0 by h is cancel. So limit h tends to 0, h tends to 0, 1 is equal to 1. Okay, this is equation number 2. So from 1 and 2 both the values are not equal. Left hand derivative is minus 1, right hand derivative is plus 1. So from 1 and 2 left hand derivative is not equal to right hand derivatives. Therefore f of x is not differentiable at x is equal to 1. Okay, so next problem, 10th problem. Prove that greatest integer functions defined by f of x equal to greatest, this is called greatest integer function of x. Okay, x is greater than 0, less than 3 is not a differentiable at x is equal to 1 and x is equal to 2. Okay, there are two problems here. Given f of x is greatest integer functions. Okay, greatest integer function means it is a greatest integer less than or equal to x. Greatest integer less than or equal to x. Okay, for example, I am taking a greatest integer of 2.5. Okay, so I am taking this point as 2.5. What is the greatest integer less than 2.5? 2. Okay, I am writing 2 here. Okay, similarly, what is the greatest integer of 4.5? It is equal to 4. So this is the greatest integer value. Okay, similarly, greatest integer of minus 5.6. What is the greatest integer less than minus 5.6? It is minus 6. Okay, not 5, not 4. Okay, minus 4. Similarly, greatest integer of 3. Greatest integer of 3, same 3. Okay, so no value in left side greater than 3. So greatest integer of 3 is 3. Okay, greatest integer of minus 4 is what? Same minus 4. If it is in greatest integer, if it is whole number, positive number, negative number, that is whole number, we write as it is. Okay, the greatest integer of 2.5 means we take a number, we take greatest number less than 2.5. Okay, before 2.5, what is the greatest integer, 2 is the greatest integer, we know. Similarly 4.5, 4 is the greatest integer. Okay, for minus 5.6 I am taking minus 5.6. okay, this point is minus 6. So before minus 5.6, okay, what is the greatest number? So minus 6. okay, I am writing, so greatest integer of minus 5.6 is minus 6. okay, this is the detail about greatest integer functions. okay, now we show that the function is not differentiable at x is equal to 1. okay, now write the left derivative formula at x is equal to 1. Left hand derivative at x is equal to 1. okay, is equal to, so left hand derivative at x is equal to 1 equal to, so limit x tends to 0, f of 1 minus h, because the point is 1, so I am writing 1 here, minus y f of 1 by minus h. So limit h tends to 0, function is greatest integer, so we write 1 minus h minus greatest integer of 1 divided by minus h. okay, now what is the value of greatest integer of 1 minus h? okay, greatest integer of 1 minus h, I am taking h is equal to some 0.1. okay, so 1 minus 0.1 equal to 0.9, greatest integer of 0.9. okay, it is equal to greatest integer of 0.9, it is equal to what? 0. okay, because in left side of 0.9, what is the greatest integer? 0 is the greatest integer. okay, I am drawing a number line here, this is the 0.9 here, now this is 1, this point is 0. okay, so before 0.9, what is the greatest integer? 0. Before 0, okay, so after 0 we get minus 1, minus 2, etc. okay, so greatest integer less than or equal to 0.9 is 0. okay, so similarly I am taking h is equal to 0.01, again we get the greatest integer value as 0. okay, for any in a h of negligible value, greatest integer of 1 minus h is equal to 0. okay, so limit h tends to 0, now this is 0, greatest integer of 1 is 1. okay, greatest integer of any whole number equal to same whole number, so minus h, so limit h tends to 0, this is 1 by h. okay, h tends to 0 means not exactly h is equal to 0. okay, h never takes 0 value, approaches 0. okay, h approaches 0 in left side or right side. okay, now I am taking h is equal to 1 by h is equal to, I am taking h is equal to 0.1. okay, so it become 10. okay, take h is equal to 1 by 0.01, we get 100. H is equal to 0.001, it is equal to 1000. okay, so if you take h is equal to 0.1000, put 1000 0 and write 1, we get a huge value, that value is called infinity going on, that value is equal to infinity. okay, so when h tends to 0, 1 by h tends to 0 means not exactly equal to 0. okay, so it is nearer to 0, it is nearer to 0, h is always take positive value, h approaches 0 means it is nearer to 0, taking h value as 0.1001. okay, so 1 by 0.1001 is equal to very huge value, that value is infinity, take it as 1. okay, you understood? Similarly we find a right hand derivative at x is equal to 1, so limit h tends to 0, f of 1 plus h minus f of 1 divided by h. okay, so limit h tends to 0, Now this value is greatest integer of 1 plus h minus f of 1 means greatest integer of 1 divided by h. Okay, so greatest integer of 1 plus h is equal to, I am taking h is equal to 0.1 here, so 1 plus 0.1, it is 1.1. okay, greatest integer of 1.1 is 1. In left side of 1.1, what is the greatest integer value? 1. okay, so limit h tends to 0. Now this value is 1. This value is also 1 divided by h. So limit h tends to 0. 1 minus 1 is 0 by h. So h is not equal to 0 here. Okay, don't put h is equal to 0. It becomes 0 by 0. In bottom, 0 is not allowed. Okay, so h is equal to very small negligible value. I am taking as 0.01 etc. So 0 by anything is 0. Okay, so limit h tends to 0. 0 is 0. This is the right hand derivative. Take it as 1. From 1, left hand derivative value is infinity. Okay, in 2, right hand derivative value is 0. They are not equal. Left hand derivative is not equal to right hand derivative. So therefore f of x is not differentiable at x is equal to 1. Okay, similarly, now I am next question is at x is equal to, we show that function is not differentiable. Okay, so now I am writing in left hand derivative at x is equal to, here is the same formula. So limit h tends to 0, f of 2 minus h minus f of 2 by minus h. Okay, function is again greatest integer functions. So limit h tends to 0, it is 2 minus h, f of 2 is again 2 here by minus h. Okay, what is the value of greatest integer of 2 minus h? I am taking h is equal to 0.1 here, it is 2 minus 0.1, it is 1.9. okay, so greatest integer of 1.9 is again 1, so which is greatest integer value of 1.9. okay, so this value is limit h tends to 0. Now this value is 1. okay, greatest integer value of 2 is 2 here by minus h. So limit h tends to 0, minus 1 by minus h, that is 1 by h, minus minus get cancelled. So limit h tends to 0, 1 by h, again we get the huge value. Okay, so infinity. Next write right hand derivative value. At x is equal to 2. Plus h by h. Okay, so limit h tends to 0. F of 2 plus h means write 2 plus h, greatest integer of 2 plus h minus f of 2 by h. So 2 plus h means I am taking h is equal to 0.01. So 2.01, it is also 2. Okay, so limit h tends to 0, 2 by h, 0 by h, limit h tends to 0, 0 by h is 0. okay, 0 by h, it is also 0. So equation number 2, left hand derivative is infinity, right hand derivative is 0. They are not equal, is not equal to right handed derivative. Okay, therefore f of x is not differentiable. At x is equal to 2. Okay, so this x is over. Next video we will see implicit function, differentiation of implicit functions. Okay, so share this video and subscribe, then only you have to update the videos. Okay.